Mobar Hussain, a passionate cloud and DevOps engineer. In this video, I will show you how to provision a multi-cloud virtual machine provisioning with Terraform and GitHub workflows. So before diving into this solution, let's share the scenario, how and why I have solved this problem. So imagine you are a system administrator in a company, and the company has a product that needs to run on a cloud VM. So in your company, a QA team have 5 or 6 staff who needs to test the product. So they need to create a VM from cloud for testing purposes. So they might ask to you, since you are a system administrator, to give them a cloud VM every time. Then what you do? So every time you go to the AWS console and create a VM for your QA stuff. So you might thinking it to give different accounts to your its stuff. There's also another issue, like it could be risk for cost management. So how you can solve it in better way? So let's understand the problem. So as I said, in your key team there are 3 or 5 staffs who frequently needs cloud VM, and as you are a system administrator, so you are giving clouds VM each of your staff doing manually, like creating a VM and share credential with your stuff. And there's a problem, so it's it's time consuming, and also you are doing the same task repetitively. And there is also dependency. Your QA team stuff needs your QA team depends on you. So, and also if you consider using separate accounts for each of your stuff, that also complexity, cost, risk, and management issues. So that's the problem we have faced, and let's see how we can solve it in a better way. So my approach is like this. Let's create a private repository, and there we will create Terraform to provision a VM, and we will set up a GitHub workflow for the automation. What is the automation? So a GitHub action will run this Terraform codes to create the VM, and it will provide us the credentials to access the VM. That's okay. So that's why we need to allow QA staff to run workflow with inputs, and in result QA staff will get the needs of a virtual machine with simple, fast, and automated way. So it also reduces the dependency, saves time and resources. QA team happy getting VM within 2-3 minutes. So this is the workflow overview. So this is our stuff. So this is our stuff, and for them we have created, this is the total GitHub repository. So they go to the GitHub action and launch this VM workflow. Then it will ask for some input, like how many the VM size and region, and also how long it will use. So these are the input that it needs to it asked from stuff. Then Terraform action will run, and it will create the resources. After then it will create a PR branch to track that a staff has created a VM. So we need to track that as well. So we have created PR with branch. So this is the this is from on-site action flow. And then the thing is how we will monitor this, and how, let's say staff does not require anymore the VM, so we need to destroy it, right? So that's why we are using another GitHub workflow that's called destroy VM. So it will run manually, and also it will run for automation, like it will run for every 2-3 hours. So what it will do, it will read PR, since it created PR here. So it will read the PR and find the schedule, like when it's created and how when it will destroy. So it will find this, and from that input it will understand which VM is expired and needs to destroy. So it will calculate this, it will list this VM, and then it will come to the destroy resource section. So it once it's confirmed, then it will start destroying these resources using the Terraform destroy action. So after then we have to clean the state file, and also we have to clean the branch and close the peer. That's all, and these two things will run when our Terraform destroy action is successful. So it's like it runs on successful Terraform destroy. That's the workflow. Now let's see the demo. Okay, so for this is our repository. You see it's a private repository. So here user will comes and go to the action, and yeah, so from here it's like this is create virtual machine. It will go, the user stuff will go there, and it will go for run workflow. And when it will run workflow, there, since this is a multi-cloud VM provisioning, so I have used two cloud provider. One is AWS, another is GCP. Okay, so staff can choose whatever it will be, AWS or GCP, and then it have to staff will needs to input like how long it will run. So and it should be like 1 hour to 72 hour, like which is 3 days. So let's say we are using for 1 hour, or let's say we are using for 6 hours. That's up to us. So we can give like 1 to 72. So we are giving 1 hour. And for this section, this is another section I have used, like as in Azure DevOps, it does not give any self-hosted runner, so we have to use runners. That's why I have added this section. So when a stuff created this VM, it also assign agent pool here. We will see that. Yeah, so there is no agent right now. So when we run this, when we will create this VM, it will automatically restart here as the agents. We will see that. So that's why I'm giving the self-hosted as the agent pool name, and we can choose region. Primarily there's Singapore, US East, and Europe. So we are choosing Singapore, and instance size like T2 micro, T2 small, T2 medium, large, or X large. In Google Cloud provider, it could be like E2 medium, E2 standard. So we have mapped all these things in this option. So micro could be T2 micro or E2 micro. Okay, so let's using micro, and this is the instance disk size. So you can choose like 20 GB, and currently it's given like 10 to 30 for testing purposes. So now our workflow is ready to run. So let's run the workflow. Okay, now it's started. Let's see here. Okay, we can see this is our GitHub action is running. So let's go there. Okay, so here it's defined the Terraform variables. Yeah, here it's defined the Terraform variables like this, and it's defined the AWS CLI configurations using credentials. You see, yeah, and this one is skipped because since the stuff chose AWS, so we don't need to configure GCP credential. That's why it's skipped here. If stuff chose the cloud provider, the Google Cloud provider, then it will skip AWS credential. Instead, it will use GCP credentials. Yeah, so and I think we are done here. So it's created the peer, it's created the okay, so yeah, let's see now. Go to the pull request. Yeah, there is one pull list already created. So here, if we go there, we can see our agent details. So this is the domain name I have used. So for that we have used a Cloudflare API, and this is our agent name, and this is the public IP of our VM. So if we would like to access this, we can copy this command. Since currently I am using only me, so that's why I have used SIS key as the private value as in variables here. Yeah, so I have used the variable here, but if when we need to use for multiple stuffs, then we have to generate and upload on respective user. So yeah, that's it. Now let's try to log in our VM if it's accessible or not. Yes, so we can reach. Yeah, so since this is assigned with a domain, right, so let's try to install nginx and see if our domain is accessible or not. Okay, since it's started installing. Yeah, so nginx is running. Let's enable systemctl enable now nginx. Sorry, we have to use sudo. Yeah, let's see. So we'll use this domain name here. Yeah, we cannot use HTTPS, so we see our domain is also accessible. So the user can use this domain as if needs, and also can access the VM, and it's also connected with Azure DevOps as the agent. You see, this agent is already online, so anyone can run in Azure DevOps pipelines with this VM also. Yeah, that's the solution where I have used here. Now let's come to the point, how can we destroy this VM? There's also another things we need to consider. So for that we have used another action that's for that is called destroy virtual machine. So basically it runs like every 2-3 hours, and it will automatically define the expired VM, and it will destroy this virtual machine. So for now let's update. You see here the creation date and schedule to destroy, so it will destroy after this time. So for our current scenario, let's update this with some old date so that it destroy automatically. So yeah, we have changed the date with some past value. Let's update the pair. Also, if user wants to use it longer, he can choose some future like 13 December, so it will run for up to 13 December as well. This way user can use it for longer time. Okay, so we have updated with old data. Now go to the action, destroy virtual machine, run workflow. Yeah, I think it's started. Let's see. Okay, our destroy virtual machine started. Let's see. So now it will destroy this VM with Terraform destroy action, and also it will remove the agent name from this list, and it will also remove this this DNS from Cloudflare. We can check it here, -cloudflare.com. see the DNS here. I think it's already destroyed. Is that? I don't see it. Yeah, let's see. Is that? Is that? Is it destroyed already? Let's see. I think it's already destroyed. Yes, it's destroyed before. Here is this. Oh, okay. So we have used. We have used Cloudflare Terraform registry. That's why when it's destroyed the Terraform resources, it also destroy this DNS record. We'll see the code flow right now. So now let's go to the pull request, and it's closed, and also the branch also destroyed, and the peer also closed. This is the whole scenario. Now how we did that. So there are few challenges when we are solving this problem. We face few challenges, like we have to define how this Terraform state file will be managed, and also how we can map the input variables for different cloud provider, and we have to consider the Terraform destroy action also, and if any action is failed, how can we destroy some resources that's created. So these are the few challenges I have faced, and I have solved gradually, and this is the solution I have found. Like, we can use the dynamic state key with remote backend S3 bucket, and each time it create PR body with information that we need to destroy. Like it needs the agent run ID to find the actual state key file, and also it needs we need the DNS information to destroy. Yeah, that's the things. And also ensure state file exists on failure actions. So if any action is failed in the mid of the run, so we have to ensure that that state file is exist, and we can use that state file to destroy resources as well. So what we can improve in many ways, like we can set up some integration to upload private key file for stuffs like Discord, Slack. Okay, that's the improve, and now let's see the code. So this is our Terraform code, and here's the create VM. So one is for AWS, another for GCP, and Cloudflare is for using DNS record. And this script is to use for setting up the Azure DevOps agent. It will install some package. So inside the AWS, this is our, you see there is no key file because this backend key file is chosen dynamically. There is our main.tf. We have used the module for Cloudflare. Now I think we don't need to. Now let's check the GitHub action. So this is our launch VM. So here there are a few inputs option, like user can select target provider, AWS or GCP, how long it will run, 2 hours or something. This is the default value, so user can choose input with between this range. And this is for Azure DevOps agent pool name and the region, instance size, disk size. So, and this is the jobs steps. So it initially it's validates, because if any wrong inputs is provided, so that it can exist instantly to reduce GitHub action runtime, because we know GitHub charges for running GitHub action workflow per minute. So we have to ensure that we are not using unnecessarily workflow minutes. And this is for mapping the inputs for region mapping, instance mapping. Yeah. Then we have configured AWS and GCP credential. We have set up the Terraform variables that we need in. So we have, yeah. Then we have used SSH key from the GitHub action variable, but when you are dealing with multiple stuff, we have to change this to generate unique SSH key and upload either on any Slack, Discord, or user email. That depends. Then it's started creating the Terraform resources, provisioning the resources. Then we have saved the agent information. We generate the metadata to create our pull request. So then in this pull request, we have updated every information that we need for us and also for the user. There's the launch VM workflow, and this is the destroy VM workflow. So it runs every 2 hours automatically, and we can run also in manually. This is for workflow dispatch, and this is for generating. We know when we run Terraform destroy action, we also need some variable dependency. That's why just using it does not need to be validated, but needs some value. Then from this is very important section, we have find and destroy exploit. So in this section, we read this pair and we extracted the information like find the schedule of destroy VM, run ID, agent name, pool name, provider match. Because according to provider, you have to move into that directory to run this Terraform destroy action. So yeah, if it's GCP, then we have to configure GCP credential, and if it's AWS, then it also configure AWS credential. But we have used this section because we are using AWS remote backend S3 bucket. That's why we need always AWS credential. So yeah, it's started here. So it's run for every agent and it's destroy VM. Then it also track is it success or fail, because if it's success, then we can destroy the S3 bucket key file. If it's failed, then we have to keep S3 bucket so that we can run also in manually as well. And this is for agent, DevOps agent, as Azure DevOps agent. At the end, we have to remove state files. Yeah, that's, and also we have closed the PR here. This is the whole scenario we have used for this project. I think we are done.